It's nice to be by the ocean because sometimes it's cooler on the ocean than it is inland. Suppose that a house is 1 mile inland from the ocean along a road that leads directly to the ocean. The air temperature varies linearly along the road. 1/6 of the way from the house to the ocean, the air temperature is 80 degrees Fahrenheit. 2/3 of the way from the house to the ocean, the air temperature is 74 degrees Fahrenheit. What is the air temperature at the house? This is a question which may look like algebra. It may look like something you can draw a picture for, and has something inside it also that I want to show you as an interesting idea on how to solve these kinds of questions. One of the easiest ways to do this is to first try to draw a picture that represents what is happening. Here we have the house and we have the ocean. Now, we know that the temperature is changing linearly. What that means is that when I go a certain distance and I go the same distance, then the temperature moves by the same amount. And if I go a certain distance and a fraction of the distance, the amount that the temperature changes in this fraction is the same ratio as this distance to that distance. Okay, well, what we know is that 1/6 of the way from the house to the ocean, there's an air temperature, and 2/3 of the way, there's another air temperature. I chose these numbers, 1/6 and 2/3, in order to have this nice coincidence about thirds and sixths. These are very nice, and you can actually draw it, where you can have the 1/6 and 2/3 by cutting into 6 parts. If these are 6 equal parts, then I know that at this point the temperature is 80 degrees, and I also know that at this point the temperature is 74 degrees. In this picture, it's actually then very easy to see that for each of the parts, I have 3 parts in here, so I can visually solve this and see that there should be 2 degrees here, 2 degrees here, 2 degrees here, and the answer here is 82. This is what I can do when I can look at a picture. Sometimes it's not completely easy to look at a picture, and so I want to show you another way of doing the same problem. That other way is based on an interesting idea which starts like this. What if I didn't ask you that temperature? What if instead I asked you the temperature right in between those 2 points? Well, that's fairly easy because it varies linearly, so the temperature at the middle of those 2 points should be the average of the 2 numbers. Okay? I'm going to write this average in a slightly different way. I'm going to say it's 1/2 times 80 plus 1/2 times 74. Now I'm going to ask about a different place. What is the temperature at this point? Well, that seems like a very silly question. The temperature at that point is 80. But I'm going to write it in the funny way, where I write 1 times 80 plus 0 times 74. Next, I'll ask you what's the temperature here at the 74. I'm going to write that in a strange way, where I'll say the temperature here is 0 times 80 plus 1 times 74. Now that you see how I'm writing this, what do you think the temperature is right here? On the one hand, I already know that it's going to be 78 because it's 2 less there. Let's see if this same pattern works. Where this same pattern is, here I had a 1, here I had a 1/2, here is a 0. I'm looking at the coefficient of the 80. In fact, this coefficient of the 80 is going down, and the coefficient of the 74, the thing I'm multiplying by 74, goes from 0 to 1/2 to 1. It's measuring what fraction of the way along I am. That's how much to multiply the 74 by. So actually this thing here is 2/3 of the 80 plus 1/3 of the 74. That's because, well, let's first calculate to see if this is indeed true. If I was to simplify this, actually at first it doesn't even look nice to simplify. But if I take everything over 3, 2 times 80 is 160 plus a 74, and that's equal to 234 divided by 3, which is just divisible by 3. 3 times 7 is 21. 3 times 8 is 24. Indeed, it works. Actually, the reason why this is true is because of this word linearly. Let me draw another picture. Here, I have this long road. Here's the halfway point. Here's the 1/6, 2/6, 4/6, and 5/6. Now, as I'm going from this point right here, where the temperature is 80, to this point here where the temperature is 74, we said that the temperature is varying linearly. So if I draw this as a graph, the temperature should look like this. This is not the x-axis, but I'm just drawing a line. If I have a line, the equation of the line has to be linear in x. So in particular, when I'm thinking about, let me think about axes like this. Let me actually think of new axes where my x equals 0 is here, and this is where my x equals 1 is. Because that x that I'm counting is actually the x which is what I multiply by the 74. If I think about it this way, and I know it's going to be a line, then I can actually find the equation of a line that goes through these 2 points. The points are 0, 80 and 1, 74. The way to do this, you can do this with slope-intercept form. Because if I have these 2 points, 0, 80, and 174, then the slope is equal to, simply from 0 to 1 is very easy. I just look at the difference in the y's, which is -6. And so the slope-intercept form tells me that the equation of this line is y equals -6x plus 80, the y-intercept. So now, if I have it this way, I can rewrite this in terms of the 74 and the 80. You see, what I actually had in the other equation over here was I had x times 74 and 1 minus x times 80. Let's see if that works. Is this equal to 1 minus x times 80 plus x times 74? Well, if I check it, this gives me the 80, and this is minus 80, and that's plus 74. So they are indeed equal. So this actually shows you a way to find any point along this. If I have 2 points and I want to know the temperature part way along, I can just look for the fraction of the way along I am. And this is actually well known. This is a method that is called the weighted average of these 2 numbers, 80 and 74. The normal average is just the one right in the middle. The weighted average is where you go part of the way there. And in this question, what I also want to show you is that you can also even do the weighted average where you have a negative x. And in this case, since I see this is 3 parts, actually I could do the same thing with x equals minus 1/3. Because if that's x equals 1, this is x equals minus 1/3. This is not the most efficient way to do the problem, but I'm showing it to you just so you have many different ways of seeing the same mathematics. If I put in minus 1/3 into this equation, well then what I get is 1 minus 1/3 is 4/3, 80, minus 1/3, 74. Which if I simplify this gives me over 3, 320 minus 74. Finishing that up, 320 minus 74 is, it ends with a 6, 32 minus 7 is 24, 246 over 3, and so this simplifies to 82. And so we have seen ourselves get to the same answer in 2 different ways. Ultimately, this question is not a very hard question in the sense that you can just draw a picture and solve it. But I wanted to choose the numbers and to use this to introduce also the idea of weighted average.